Welcome to hurricane season 2024 in the North Atlantic, Gulf of Mexico, Caribbean. This is Andy Revkin, sustained what? 40 years on the climate beat, trying to help people stay sane and productive and to have an impact as you face the usual headline flood around hurricanes, global warming, and the rest as this year plays out. I reached out to one of my tried and true experts, Tom Knutson at the Geophysical Fluid Dynamics Laboratory in Princeton. It's part of NOAA, and his work for decades has been to assess the science and do the science related to how global warming from CO2 buildup, pollution changes from old-fashioned sooty, sulfurous stuff, and patterns in the Atlantic Ocean and the rest combine to shape hurricane risk. And of course, the biggest thing shaping hurricane risk is what we do in the expanding bullseye we've built along shorelines and in floodplains. His website is at gfdl.noaa.gov, or just search for global warming, NOAA, and GFDL, and you'll find it. Here's Tom Knutson. And when the question comes up about climate change, and you think about the way people look at a season like now, where what's the kind of thing you say to, again, the average person you might run into?
It's complicated, actually. Climate change and hurricanes is a bit of a nuanced topic area. There are some things which are pretty clear. The ongoing sea level rise, which is going on globally and also affecting the Atlantic, is just going to create more problems for coastal flooding, because everything's going to be riding in on a higher background sea level.
That baseline is just going up, right?
That's right. And that has been attributed to anthropogenic forcing. So you can sort of draw a line there between anthropogenic forcing through sea level rise to these potential for greater impacts from storms, because they're riding in on this higher background sea level. So that one, people need to be aware of.
So basically any
changing world we're living in.
Any coastal storm, hurricane particularly, is coming at you with sea level higher than it would have been without global warming.
That's correct. For most parts of the globe.
Yeah. So that's the simple part.
Yeah, and then I kind of go down and I go from higher confidence down to lower confidence. So the next thing that would show up will be rainfall rates of tropical cyclones. So another thing that happens with global warming is the atmosphere holds more water vapor. The water vapor in the atmosphere goes up at something like 7% for every 1 degree Celsius rise in the sea surface temperature. So this warmer atmosphere is systematically holding more water vapor. Now, a hurricane's like a big engine which is converging this water vapor in toward the center, is converging air in toward the center of the storm, and the air is carrying with it the ambient water vapor. So when the whole system has more water vapor in it, then this whole process of air convergence and moisture convergence toward the center of the storm is ramped up by that, at least by that 7% per degree Celsius.
Right.
And maybe getting even more if the hurricanes themselves are getting stronger. So, but what that's leading to in models is a very clear signal of increased rainfall rates out of hurricanes in our climate models. Interestingly, we haven't really detected this in hurricane rainfall data yet. We're looking for the signal. There have been a few interesting studies out that find some global signal over the last 20 years. It's a very short time period, and that has a different spatial character than the one that we find in models. In the models, it's greater increase near the center of the storm, and in these observational studies from satellite data, it's something more out in the periphery of the storm and not near the center. But so they may be seeing something else. But anyway, in terms of detecting this change, we're still a work in progress. IPCC has detected now increases in extreme rainfall in general over many land regions where there's adequate data. So we fully expect because of the physical mechanism is fairly straightforward. IPCC has already detected it in precipitation, extreme precipitation in general, and we see it consistently in models. We fully expect that this is going to happen in the real world. We're just waiting better data to make the confirmation in terms of detection attribution. So, but, yeah.
And I'll just step back briefly just to note that on some of these points, waiting for the clarity and the science to develop a policy can be mistaken because of some of the other aspects of the global warming problem. CO2 being a long-lived gas that's accumulating. Do you? I mean, you don't get into the policy particularly, but is that one way to think about it? That if we're just sitting like waiting for the next IPCC report for clarity on some of these things, can that be kind of a fool's errand?
All I'm saying is that the science is not complete yet,
Yeah.
and we're in the process of learning, and this learning will continue to go on. And this is one area where we haven't sort of dotted all the I's and crossed the T's in terms of detection and attribution, but we still have. I have here medium to high confidence. I think IPCC may have high confidence in this.
Right.
So I tend to not go to high confidence until there's a detected attributable signal. But
Yep.
Okay. So, but I think it's very consistent in models, and so we're pretty confident that that's on the way and the work's probably already ongoing. We just don't have the data to detect it. But we haven't, as I said, we don't have the kind of evidence for that we have for global mean temperature or something.
Right. So let's get into the intensity.
Yeah. So models also are projecting higher intensity of tropical cyclones in a warmer climate. This has been something which has been a research result going back to, I think, Kerry Emanuel's early work on potential intensity of tropical cyclones, and I did some early work on dynamical simulation. When we look across modeling studies, we find about 1 to 10% increase, or maybe roughly 5% increase for a 2 degrees Celsius global warming scenario. So this is what we tried to look across a bunch of studies and sort of convert all their work into a common 2 degree global mean 2 degrees Celsius global mean warming construct for convenience, so that we could combine them all together and get a single distribution. And that distribution is clearly skewed positive. Almost all models showing an increase. But this is a smaller change than what we talked about earlier for the rainfall. The rainfall was 7% increase per degree Celsius. So this is more like 2.5 degrees per degree Celsius, maybe even a little bit lower than that in the Atlantic. So we haven't nailed this down in terms of detection attribution. There is a very slight increase globally since 1980 or so in tropical cyclone intensities globally. There's a big increase in the Atlantic, by the way, since 1980 in tropical cyclone intensity.
Right.
There's a big increase in a lot of things in the Atlantic since 1980.
Yeah,
in numbers of major hurricanes and things like that. But I'll get to that in a moment.
Yep.
That's Since 1980, a lot of things have been increasing in the Atlantic, but we're not quite ready to say, well, that's a global warming, greenhouse gas induced influence. That may be something special that's going on in the Atlantic, which I'll talk about further in this post. Then the global proportion of tropical cyclones that reach very intense levels is projected to increase. So we're not talking about the number here. So there's the number and then there's the proportion. So
right.
And that's important. So the total number may not go up. It depends on because we're also projecting on average a decrease in the total number of storms. So there's some things going in both directions here. But from our modeling work, and there's also some related work by Jim Cosson looking at, in his case, he was looking at the proportion of hurricane fixes which are observed in hurricane intensities that are at category 3 or higher. He's shown that globally that has been increasing since around 1980, and it's also been increasing even more strongly in the Atlantic basin. But even if you take out the Atlantic, the rest of the globe is still increasing. So IPCC has medium confidence that what Cosson is seeing is outside of natural variability. We have also, we're seeing this in climate model projections, but now we're not comparing the same thing because Jim Costin's looking at historical period and we're looking at the future. We're looking at a greenhouse gas dominated signal. He's looking at something which is over the last 40 years, which may have some aerosols and greenhouse gas and natural variability influences. So that's why we cannot at this point just say, well, what Costin is seeing is a greenhouse gas induced signal. Not at this point. Again, it may be the initial stages of that, but it's still something still to be determined. That's why we say this seems to be outside of natural variability, but we're not yet attributing the observations to anthropogenic yet. So, yeah. So those are the things. Those are the, I guess, the headline projections.
Right.
What we're saying. So, kind of going down in confidence and I haven't talked about tropical cyclone numbers here, but that's lower in confidence and maybe decreasing. In fact, the typical model is showing a global decrease, projecting a global decrease in tropical cyclone counts overall, but not all models. There are a few exceptions.
And is that because I think I've heard for decades that the idea is essentially as the higher latitudes get warmer, you're reducing the energy imbalance between the equator and the pole. So the whole system is kind of quieting down, or is that too simplistic, or is that wrong?
We're not even sure why it's happening yet in models. I think maybe what you're saying is too simplistic. It's not a consensus view. But people are looking at the role of the formation of seeds and whether the rate at which tropical cyclone sort of proto-tropical cyclone seeds are forming,
right,
changing with global warming and things like that. So, and also, whatever the mechanism is we're talking about, there are a few studies that violate it, that actually have increasing tropical cyclones or no change. Kerry Emanuel's statistical dynamical framework is one in particular, I think, because it's used a lot, and it's a bit of an outlier, showing more of an global increase of tropical cyclone numbers compared to the typical dynamical models. So that's why we have somewhat low confidence in what's going to happen.
Yeah, and is that some of that? I've talked to Kerry since my very first story in 1988, and I guess you got this modeling challenge of hurricanes. Even though they feel very big, they're very small features of the Earth's system, the atmospheric system, and so modeling them is one task, and modeling how they relate to the big picture is another task, it sounds like.
Yes, and another problem we have is that we don't have a great observational record, a century record, say, of global tropical cyclone activity over all basins. We just don't have that because of lack of satellite coverage and so forth prior to the mid 1960s or late 1960s. So the data that we do have shows no trend. We have some data since 1970 or so, no trend in global tropical cyclone frequency. In fact, even going back to Costin's paper, I think that there was a follow-up study on that, which was finding that, yes, he was finding an increase in proportion of category 3 to 5 fixes, but in the follow-up study, they were indicating that was due to some overall decrease in numbers. So the proportion of category 3 to 5 was going up, but total numbers were going down, so that there was only a slight change in actual numbers of category 3 to 5 fixes. So anyway, that's one of the reasons why we're not too confident about future projections of tropical cyclone frequency, because there's no smoking gun trend that we are aware of in global data on this.
Yeah, one study that really chastened me, starting around 2000, I began talking with Jeff Donnelly and others who work in paleotempestology, this field of paleoclimate work where you're looking at past history of big storms through proxies, through indirect records like beach sand getting washed over a beach into the muddy marshes leaving a kind of a history book in the mud of past storms. And in 2007, there was one of the studies that he and others did, looked in a multi-thousand-year record for the Eastern Caribbean, Vieques and other spots where they did their drilling, their coring. And as you see here, his study finds hurricanes frequent in some cooler periods. It does feel, though, that science is still, you'd have to core beaches all around the world to get the statistical history book that you're saying is kind of still missing.
For the global, but it's still of some use, I think, even to have a very long record for just regionally here in the Atlantic. That in itself has some interesting stories to tell, I think, as some of this work you're pointing to has been pointing out. And I think that these types of paleo studies, say for the Atlantic, to my knowledge, are not really pointing toward anything unusual about the, say, the last 100 years of behavior. That it's not analogous, I guess, to something like the Northern Hemisphere temperature reconstruction, which is so-called hockey stick, which has this clear break and an accelerated warming late in the record. These tropical cyclone records are not producing something like that. They're producing something that's more ambiguous. Not much of a indicator of an increasing signal during the anthropogenic since 1900, say.
Yeah, as a journalist, it's kind of really chastened me to not necessarily avoid words like unprecedented, but to really pause. Like when Hurricane Michael hit the panhandle of Florida, there were a lot of headlines about it being unprecedented. But I talked to Cambio Liu at Louisiana State, who has done some of this work along that area, and he said, "No, of course not." It's just so defining terms. In other words, as a journalist, when someone says this is unprecedented, or this is a new phenomenon, or this is global warming incarnate, I kind of like have this internal mechanism. Just the first question I ask is unprecedented since when, in terms of how you're, gauging what's going on. I don't know if that feels appropriate. Do you have your own recommendations when people are looking at headlines and getting freaked out about things?
Well, it is important, I think, to look at the data, and when we're lucky enough to have very long records, we have to treat them with caution too. These are not pure hurricane observations, or in some cases
right, because they're very specific points on the map, and right, because a hurricane could have hit 5 miles away and you wouldn't see it.
Right, it's very site specific, but then that it gets, but also it has a very long 5,000 years is a long time. So sometimes you trade off this having data everywhere for having a very long record at a particular location. It gives you some information, I think. But yeah, I think it is important to keep the data in mind because, as I say even on this website, that we recognize there is detectable anthropogenic influence on global mean temperature, and IPCC makes a very compelling case for this. But it's just a different ball game, I think, for tropical cyclone activity and Atlantic hurricane activity and so forth. There's not that kind of a clear smoking gun, and so we have to be a little bit more careful in making attribution claims, even sort of event attribution claims and things like that, because we don't have as strong backing that we have for say global mean temperature. So
right,
and this point you're highlighting here, that's an important data point. I think we look at the U.S. landfalling hurricane record, and Chris Lancy, who's expert in this past hurricane observations, is reasonably confident in that record going back to say 1900. So you have now 120 years of record for U.S. landfalling hurricanes, which are a small fraction of the global total of tropical cyclones, admittedly. So you can't say this is not global. It's not a thermometer for global activity, but it is a thermometer for U.S. landfalling activity, and that shows no trend since 1900, really. So in numbers of hurricanes, and also in an updated study that Gabe Vecchi, Princeton University led, that I was a co-author on, we found there's also no trend in U.S. landfalling major hurricanes, and even after even if you're looking basin wide, and you make some adjustment for changes in observing capabilities, we don't find much evidence for a trend in Atlantic major hurricanes, even basin wide, after one or major hurricanes, even after one accounts for the changes in observing capability. Right. There's the paper that you've highlighted. So I think these. So when we're talking about frequency in the Atlantic basin, then we're seeing no real trend since 1900 in the Atlantic in hurricanes or major hurricanes. So that's an important data point to keep in mind. And again, this is looking over a century where we've had a lot of things going on. We've had changes in aerosol forcing, we've had greenhouse forcing and building up and things like that, and perhaps even natural variability. A lot of complicated things going on, and but at the end of the pipeline there, if you look at what we're measuring at the coast, it doesn't have a trend since 1900, which I think is interesting and important to keep in mind.
For sure. And here's from your from the website again. In summary, it's premature to conclude with high confidence that human-caused increases in greenhouse gases have caused a change in past Atlantic hurricane activity outside the range of natural variability. That business about landfalls is very important, of course, because that's where everyone lives. I've recently been tracking, I guess some meteorologists call the hurricanes that in the Atlantic that kind of curve north, fish storms. Like, if you have a hurricane and it doesn't impact human affairs, it's not a disaster. So that's the things that we care about are landfalls. I don't think is there a section on one of the issues that's been hot in the press recently is rapid intensification, storms, moving over hot water and that kind of thing. Is that still, where would you gauge the maturity of that question?
There is a section in here where I talk a little bit about rapid intensification. I was co-author on 2 of Kieran Batia's papers on this subject. Yeah. So we are seeing increases in rapid intensification, fraction of storms undergoing rapid intensification, again, since 1980 in the data. That, like everything else, has been going up in the Atlantic since 1980. We tried in one of Karen's papers to compare the trend we were seeing to natural variability, simulated natural variability in the Atlantic basin. Mm-hmm. We had one model available that simulated long control run, long natural variability segments of hurricane activity. And so we found that the observed trend was very much at the edge of the distribution, like the 98th percentile of the model simulated variability. So that is one way of claiming that the change we're seeing since 1980 may be something that's coming outside of natural variability. But again, this is not a highly confident statement because it's based on one model, and we're not really sure how well models can actually simulate this natural variability level for what we're talking about. But it's the model also simulated an increase in rapid intensification in the greenhouse due to changes in historical forcing and also future greenhouse forcing. So it's This increase in rapid intensification is in the direction that we expect greenhouse gases to lead. We're just not sure yet if what we're seeing in the data over the relatively short period since 1980 is a greenhouse signal or some combination of natural variability in greenhouse warming or what. So it's still we're still kind of in a premature state on that, but it's an important issue. Rapid intensification can lead to a lot of forecasting headaches and so forth. So it's something that we want to keep an eye on. And we also, of course, finding this signal to some extent globally. I think it's a bit stronger in the Atlantic than other basins, but Kieran's study also was finding it was emerging from the background noise in our second study was statistically significant globally as well. So since 1980 or so.
Right. And this night, you mentioned 1980, and I've done conversation before with Kerry Emanuel about, earlier you mentioned this greenhouse gases, aerosols, internal variability. Many things are in motion through this period. And if you're okay with it, let me see if I've got it here. I want to just play. It's a very short clip of him from an interview we did. And oh, hold on, I've got to play it a different way. Sorry. Let's see if this works. And it's about the growing in evidence that aerosols, pollution, have made a significant impact in the Atlantic on hurricane patterns.
That was really quite an interesting finding. And this huge increase in hurricane activity we've seen in the Atlantic since the 80s or the early 90s is, as far as I can see, almost all of it's a recovery from this hurricane drought. There might be a little bit of global warming signal in there, but I don't think we'd ever tease it out, at least not up till now. But it is, on the other hand, an example of human-caused change, if you will, in the regional climate.
Well, that's super interesting. Does that show up mainly in storm intensity or duration?
All of those metrics, yeah, they all sort of changed in concert. Storm intensity went down and came back. Storm frequency went down and came back. And I don't remember whether duration did that as well, but I wouldn't be surprised. It was a pretty big signal, and a lot had been written attributing that to an oscillation called the Atlantic multi-decadal oscillation. And although we see signs of such an oscillation, it looks like it's more decadal and much more confined to the far North Atlantic, not so much the tropical Atlantic.
So he was talking there about the work on aerosol pollution, particularly in Europe. This is the work of one of his PhD students who's now a PhD and on into his career. And also there's work by Hiro at NOAA, looking at other aspects of pollution, sooty, smoggy, sulfury air pollution and its impact on hurricanes in the same basin. Is that, it feels to me, looking at that data and those studies, like it's pretty established now that that's the thing that can most easily explain this surge in hurricane activity in recent decades. I don't know if it feels, if that's already reflected in the IPCC report or your summaries.
Well, actually, I would disagree with your assessment. I
That's
think
why I'm asking you. I'm saying it seems to me as a lay person, right?
Yeah. So my colleague Hiro Murakami has done some very nice work on this, showing in a model simulation this increase in tropical storm frequency in the Atlantic Basin since 1980 is partially explained in his model by the reduction in aerosol forcing over the basin during that time period. But it's not the model doesn't fully explain the trend. Now, it could be as Kerry's Kerry and his colleagues have shown, his student has shown, it could be that dust is also contributing in a way to this forced signal. My other colleague, Rong Zhang at GFDL, is an expert on this Atlantic multi-decadal variability. By that, I'm referring to more of a natural variability that involves changes in ocean circulation, or the Atlantic meridional overturning circulation, which is sometimes called AMOC for short. And Rong has argued that some aspects of what we're seeing in the Atlantic Basin in historical data and so forth are really more consistent with an internal variability explanation for the multi-decadal variability, as opposed to being forced by aerosols. We have to remember now that aerosol response, forcing in response to climate change, is not a very well-defined part of the puzzle from climate models. There's still a lot of uncertainty in this whole aerosol forcing and response business. So
Right.
One should not take climate model simulations too literally, I think. But so in my view, we do have three candidates: greenhouse forcing, sort of aerosol, and I would lump dust in with that, along with just internal variations. And I would not, depends on the metric you're talking about, but let's
Right.
say something like major hurricane frequency or something like that, where we had this drought. It was high back in the 50s and 60s, and then we had a drought for a few decades in the 70s and 80s, and then from about 1995 on, it's been more in an active era. So what's causing that big multi-decadal swing? Well, first of all, since it's swinging down and up, I would agree with Carrie, that's a little hard to pin that on greenhouse gas forcing, which we expect to be more of a linear type of trend. But so how about the aerosol versus the internal variability? I think that's still an open question. There are advocates, there are really two schools of thought on this. And I think that when you talk to people from one school or the other, they seem confident about their the contribution of their process. But as to where it all ends up being in the mix, what the relative contribution is of aerosols versus the relative contribution of some type of internal variability, I think is not yet well settled. So anyway, but it does have, I think this has some interesting implication though for the future. So let's leave greenhouse force response aside for the moment.
Yeah.
If this was sort of just aerosols, that there was strong aerosol forcing for several decades, and then when that decreased, then you had this rise up of activity in the Atlantic, then that's pretty much a one and done. I think that there's not much more reduction of aerosol that you could have to make things go higher.
Right.
And also, we're not expecting aerosols to emerge on the scene and make things go lower again. So in that sense, maybe we would expect things to have gone through this hurricane drought, and now it's just going to maintain at some relatively high level.
Right.
But if you view the system as more one of being affected more by internal variability, then one could envision the possibility of going back into another hurricane drought-like situation in the coming decades at some point. So
in other words, that sounds like that one could be resolved. That question could be resolved through observation.
As time goes on, we're going to learn more, and it will be interesting to see what happens to hurricane activity, and then revisit this question. Because as I say, I think science is a learning process, and here's some place where I think there is definitely an opportunity for more learning. As time goes on, we get more data, more decades, and then this aerosol forcing episode kind of recedes in the rearview mirror. Then what comes next, and what does that mean? And by the way, Hiro Murakami's model, which does a pretty good job of simulating the trend pattern globally of what tropical storm frequency did since 1980, and his model is kind of unique in that sense, which gives the model some credibility. But that model also is projecting long-term decreases in Atlantic tropical storm frequency due to as greenhouse gases dominate. So that's a model in which tropical cyclone frequency decreases in the Atlantic and globally over the 21st century as greenhouse gases dominate, which is rather different, I think, from Kerry's projection from his model. So again, I think going forward in future decades, there may be some opportunity as these projections are diverging. It'll be interesting to see what path the observations take, and we may learn from this experience.
Yeah. There's one last thing I want to throw at you, which is pops up every time we have a hyperactive season and some extraordinary hurricane. It's the idea that we have to go to a category 6. Have you run into that much, and that there's some fundamentally new level of hurricane coming in the system because of greenhouse forcing?
Well, our projections that intensities are going to increase with global warming, and as I said, the typical number for that was something like 5% for a 2-degree Celsius global warming scenario. So if that does indeed happen, then I would expect we would be setting records, having unprecedented intensities, because this distribution of sort of possible intensities, the upper tail of that is expanding. So we put it in sort of numerical, we try to be explicit about it. We're talking about something like a 5% increase in intensities for a 2-degree warming scenario. So that's whether you want to expand the Saffir-Simpson scale to have a category 6 or not, I don't know. It's not really, I think it's not really a science question, more in terms of communication or something. But we at least, I think the important thing to keep an eye on are these projections and whether they're on track or not. Because, our projections could be off in either direction. We could be overestimating the effect. We could be underestimating the effect. Some of the models are more like a 10% increase of intensity for 2 degrees Celsius warming, and some have practically no change. So
yeah,
so there's still a great deal of uncertainty on this. There is a consensus that things are going to the more intense side, but by how much, it's not so clear.
Right. Well, and the last thing is, and way back in 2006, you remember the early aughts were a period when there was a lot of debate in the scientific community about hurricanes and global warming. And there was this moment when Kerry Emanuel and some others threw together a letter saying, yes, these are important scientific questions, but what we all feel has to be a priority is warning communities that if you're on a coastline, or actually not on a coastline, if you're in a floodplain, even inland, you have to look around you and understand that all it takes is one to make a season like 1992 an epic season. That was a quiet season, and Hurricane Andrew was devastating. So I assume, again, in your hallway conversations, sometimes scientists are quick to say, well, more research will do X. But at the same time, the social scientists I talk to say, pay attention to what two of them, geographers, Stephen Strader and Walker Ashley, they use this expanding bullseye metaphor and map, where they show, the hurricanes are the darts, but we're expanding a bullseye of vulnerability.
Right, very much so. The increase in population and wealth and development and so forth at the coast has been very clear, and that seems to be driving a big increase in damage because there's more stuff to be damaged there. Right. That's increased remarkably over time. And so, yes, when you look at damage statistics, boy, they're going up and up and up. It's no real surprise given this increase in wealth and population in coastal regions. So if we're looking for a climate change signal, not a damage signal, but a change in the weather characteristics, it's actually, I think, kind of tricky to try to find that signal in the damage data, because you have to take out this big signal from development and so forth, and then normalize things. And I think different researchers have done this normalization and come up with different results and so forth. But I focus not so much on the damage data if I'm looking for a climate change signal, a change in the climate system itself. I focus more on the climate data itself.
Right.
But I recognize that from a damage perspective, things are really increasing, and we have to be aware of that. There's a lot of building, a lot of people live and build and so forth in hurricane-prone regions. So the damage is just going to continue to rise from that effect.
Well, this has been a really valuable conversation. Thanks for letting me check back in with you on these points. And I can't stress to anyone, whether you're a journalist or an average person, gfdl.noaa.gov/ well, just search for global warming and hurricanes and GFDL and NOAA, and you'll find this page. And it really is an excellent sort of state of science that can help you cut through the headlines and assertions around you, including any assertions I make. As a researcher at Arizona State once said, don't drink anyone's Kool-Aid. This is a point, especially with social media, I think. The audience actually needs to do a little bit more of the work. And happily, people like Tom Knutson at NOAA are providing resources that can help you do lessen the work and keep sane and keep safe as hurricane season comes again. And here we are at the beginning of a new one that's going to be pretty substantial. So thanks, Tom.